So today we will learn how to design synchronous counters. We have learned up to the design of asynchronous counters. The main difference between an asynchronous and a synchronous counter is that in asynchronous counter the clock is not given simultaneously. Output of the first flip-flop is given as the clock to the second. Output of the second is given as the clock to the third, and it goes on like that. But in synchronous counters, we will give the clock simultaneously to all the flip-flops. Thus, the drawbacks of asynchronous counters can be eliminated. Before learning how to design synchronous counters, we need to learn how to write the excitation table for different flip-flops. So today's topic is how to write the excitation table. How to write the excitation table for different flip-flops. For example, I am going to write the excitation table for SR flip-flop. First, you write the truth table for SR flip-flop. This is the truth table that we know. S and R are the two inputs. Qn is the previous state and Qn plus 1 is a new state output. So for the 0 0 condition in an SR, which means this is a memory state, so if the previous state was 0, the circuit is going to remember that state, the new state will be 0. For the 0 0 condition, if the previous state was 1, what is a new state? The circuit will remember the previous state, output is 1. So I'll write all the combinations. 0 1, previous state was 0, what's a new state? 0 1, previous state was 1, what is going to be the new state? 1 0, previous state was 0, what's a new state? 1 0, previous state was 1, what's a new state? And 1 1 condition, what is going to happen in SR flip-flop? So 0 1 condition, here S equal to 0. In an SR flip-flop, we know whenever the value of set input is equal to 0, you don't have to bother about other inputs, always the output is going to be 0. So for these two conditions, S equal to 0, output is equal to 0. Similarly, for S equal to 1, output is going to be 1. We don't have to bother about other inputs. 1 1 condition that we know, this is an invalid condition in SR flip-flop. So this is the truth table for SR flip-flop. Now I am going to write excitation table for SR flip-flop. This is very simple. You have to just reverse the truth table, you will get the excitation table, which means I'll write Qn and Qn plus 1 here, and you have to find out what are the values for S and R. This is excitation table. So I'll write all the combinations 0 0, 0 1, 1 0 and 1 1. For this condition, previous state was 0. For the next state to become 0, that's the meaning, Qn plus 1 equal to 0. For the 0 0 condition, what should be the values for this S and R? You look back to this truth table and find out the rows under which Qn and Qn plus 1 are 0 0. So this is one 0 0 condition. Again, there is another 0 0 condition. So these are the two 0 0 condition in the truth table. Qn is equal to 0, Qn plus 1 is equal to 0. For that condition, observe what are the values for S and R. In the first case, S equal to 0, R equal to 0. Second case, S equal to 0, R equal to 1. So in both cases, S remains 0 and R changes to 0, 1. So S must be 0, R can be anything. So we put a don't care here. So this is the meaning. 0 0 0 X. Now 0 1 condition. Again, look back to this truth table and find out this 0 1 condition. So this is that 0 1 condition. This is the only 0 1 condition in the truth table. For that, what are the values for this S and R? 1 0. Now 1 0 condition. Again, find out what is the 1 0 condition. This is the 1 0 condition. S equal to 0 and R equal to 1. And find out the 1 1 condition. There are two 1 1 conditions. One is here, another is here. For this, S changes from 0 to 1, but R is equal to 0. So S can be anything, R must be 0. So this table 0 0 0 X, 0 1 1 0 1 0